Hi, Assalamualaikum and good afternoon, everyone. Welcome to PAM Online Technical Talk. I'm Nani Muhammad Noor, will be your MC as well as moderator. For your information, today Technical Talk is by Wavin on solving the puzzle of rainwater and stormwater. I'm pleased to remind you that this lecture can be watched via PAM Facebook Live, but do note that CPD point is not applicable for PAM FP Live platform. So if you wish to have CPD points, kindly log into Zoom webinar by requesting the registration link by email to pamonlineseries@gmail.com. I repeat, pamonlineseries@gmail.com. Before we begin, allow me to read out some house rules for this technical talk. Firstly, on the attendance policy. Sign in and sign up code will pop out on your screen for 20 minutes. What you have to do is you need to write down or copy or memorize the code and to fill out the questionnaire form that will be projected on the screen at the end of the webinar. We are pleased to remind you, simply clicking the post does not indicate you have signed in or signed out. Secondly, any form of screen recording, sharing, or reproducing the content of this lecture in audio or writing is prohibited. Ladies and gentlemen, without further ado, allow me to introduce our speaker today, Mr. Geertjo, Global Product Manager, Stormwater Management, Wavin. Mr. Geertjo is the Global Product Manager for Stormwater Management portfolio of Wavin. With 13 years of global experience in water management, he drives the development of new products and offerings. In recent years, Geertjo was responsible for the development and launch of several stormwater management solutions in Europe. Now he is realizing the global expansion of the stormwater management business, aiming to make cities climate resilient across the globe. Before joining Wavin, he worked at Royal Haskarding DHB as project manager. He leads complex water management projects such as the design of the stormwater management for the new Mexico City airport and the design and supervision of an extensive flood management system around the city of Kigali, Rwanda. He graduated from the Delft University of Technology in the Netherlands with a master's degree in civil engineering with a specialization in water management. Without further delay, over to you, Mr. Geertjo.
Nani, thank you very much for introduction and good afternoon, everybody. Thanks for the opportunity to share my thoughts and on rainwater and stormwater management. I trust you can see my screen now, and today I would like to talk about solving the puzzle of rainwater and stormwater. Let me start with introducing you on the process of this webinar. I would like to take you through more holistically about building healthy and sustainable environments as we do as Wavin, then have a focus on the climate resilient cities and go deeper into the solutions following the drop of water falling on roofs and streets, and then following that drop into our solutions to solve the puzzle of rainwater, so to say. But let's get started and first look at this world. It has major challenges, especially when it comes to water management. A few facts. If we look at pipe systems, especially drinking water pipe system, cities lose up to 70% of all their water through leaking pipes. In developing countries, 50% of the people don't have improved sanitation. 50% of the energy today in buildings is wasted, and rainfall due to climate change is increasing by 30% in intensities. Those are facts that really need to be taken action upon. That's also defined by the United Nations. The United Nations sustainability goals like clean water and sanitation, industry innovation and infrastructure, sustainable cities and communities, and climate action. Those are the typical challenges that are also addressed by Wavin, and we want to make meaningful impact on this world with the challenges it has. And that's why we have the goal of building healthy and sustainable environments. We do that based on four pillars. In line with the challenges that I just introduced, we want to improve the distribution of drinking water and making sure that it's clean from source to tap. We focus on reacting or acting upon climate change. We want to future-proof the wastewater transport, making sure that there is sanitation for all. And we want to improve the building environment, making it comfortable and healthy living inside buildings. That's what we do as Wavin. To give you a few figures on our company, we have production plants in more than 40 countries across the world, more than 12,000 employees, and we are active globally. We have business areas in all areas where we have water, outside, below ground, for distribution, as well as the drainage of foul and rainwater, and inside the building, the supply, but also the soil and waste part, as well as the climate part, the indoor climate part. And we also do water and gas and geotextiles. We do this under the brand of Wavin and a dual brand in Latin America. Let's take the next step and zoom into the business which is closely related to stormwater management, and that is climate resilient cities. Well, there are also significant challenges when it comes to climate resilience, especially of cities. And a big driver of that is urbanization. Cities become more compact, more dense, which means that there is less space for infrastructure to drain water away, for green areas that can absorb water. And at the same time, there is more drainage discharge to sewer, and there is more demand of clean drinking water. So urbanization puts a lot of pressure on all of our water systems. Besides that, there are the three main trends which we see coming from climate change, which is floods, droughts, and heat. And especially in cities, heat is a problem due to the heat island effect. But what we also see is many of the cities around the world are actually sinking, especially because most cities are localized near to coasts, and sinking cities is a bit problems, and that has all to do with groundwater levels. And last but not least, pollution is a big problem in cities, impacting also our environments. I would like to dive into the climatic problems in a bit more detail. So if we look at flooding, and well, we made a video for those climate challenges that we face in cities. If you would like to watch that, you can scan the QR code, but I'll take you through it just in presentation mode. In cities, especially because of all the hard surface, rainwater cannot go easily into the ground. And all the hard surfaces create a lot of runoff of rainwater, and all that water has to go somewhere, and it will generally go to the lowest place. So especially in a slightly hilly environment, the lowest area will soonest be flooded. And with an increase in rainfall intensities, so more rainfall in shorter periods, that will even become worse, causing all kinds of damage. But also the other side is true. When we look at climate change, we see that the drought periods are becoming longer, which basically mean the availability of water is going down. It has effect on the environment, the green spaces in cities, but it will also impact water availability in the ground, so to say. Well, with the rainwater, when it's draining, it also takes a lot of pollution from the street. And also that is a big problem. And many times the rainwater systems are connected to our open water system. It is just draining into our rivers and seas and oceans. So the rainwater flows can indirectly cause quite some pollution. So it's very important also to have a closer look at that. That's also the one topic I will discuss a little bit more elaborately later on. But it means that we should make sure that we take oil, dirt, litter from the street, and we filter that out of our water systems. Then groundwater depletion is also a great concern. Because there is so much hard surfaces, rainwater does not infiltrate into the ground. And that means that the groundwater is not being recharged. Meanwhile, we are pumping up drinking water from the ground so that the balance is not there anymore. So the groundwater is going down. And that has also an effect on soil stabilities. And that's also one of the major causes of cities to sink, which is a very severe problem, especially if we do realize that our sea levels are rising and most cities are on coastlines. So the risk for cities to flood also from the seaside will increase when our groundwater levels deplete and cities sink. And finally, heat stress is a very important problem also caused by our climate, by not only more intense rainfall and longer dry periods, but also higher temperatures. We are now trying to keep the global temperature rise within 1.5 degrees Celsius, but that is going to be a huge challenge actually to achieve. And especially in cities, we see that the effect is multiplied by the fact that streets and buildings heat up the city, keep the heat in. And that is of big impact also on the health level of the inhabitants of cities. It has impact on their physical and mental health. And it also has impact on productivity for people working in a city. It has impact on how much people actually sleep. It has impact on the energy consumption. So heat is very much a concern that we should address. So giving you an overview of those things, I would like to add one more thing, which is important to Wavin, which is our environmental footprint. So in the things that we do, in the products that we produce, we are aiming to go for a circular economy for plastic products. So hopefully with this, I gave you a good idea on what we are as Wavin in general, but also especially on what the problems are that we face when it comes to making cities climate resilient. And what I would like to do now is go to the solutions that are there if we follow the drop of rainwater. But before doing that, it is good to realize that if we design a system, it is very much dependent on all kinds of factors on how to design it and what decisions to make when it comes to those solutions. So we need to take into account the local regulations, of course, but also what kind of space do you actually have to build something and how large should a solution be? What are the environmental conditions? But also what is the impact on the environment and what level of sustainability do we need to achieve? What kind of other things are there that actually interfere with the solution, such as traffic or below ground infrastructure? Can we make use of multiple functions on the same space? What kind of maintenance is needed? So a lot of questions that should be asked making a design. Well, I hope with the following part of this presentation, I could help you to make decisions in the right way on the solutions that we have and that there are on when it comes to climate resilience. So let's go to the solutions. Just showed you the pictures of the different impact of climate, and there already you saw all kind of solutions identified, and there are solutions for every part of the storm and rainwater management systems. And I would like to go over them all 12. It is roof drainage, road drainage, so where do we collect the water, then filtering water, transporting it and feeding into the ground, but also regulating water for either the use of it or going back into the drainage system with the controls that are needed for that. So we are going to follow the drop. During the presentation, I will focus mainly on the roof drainage solutions, the infiltration and attenuation tanks, and our urban tree solutions, but I will go over everything at least shortly. So let's get started with the roof drainage. Well, what do we mean with roof drainage? Two pictures to show that. You can see here a downpipe on the outside of the building, this white pipe that you can see on the roof. There is an outlet, and the rainwater is being drained downwards. On the right side, you see a picture in the structure on the roof on the inside with the black pipes. That is also a drainage system which is actually hanging inside the building on the roof. Well, let me dive a little bit in more detail what these systems are. So we have two types of systems. We have conventional systems and we have siphonic roof drainage systems. So what is the big difference? The big difference is that a traditional system is a system where water and air are mixed in the system. So we just have an opening in the roof, an inlet there, and a pipe just letting the water in, but that will go with air together, which means that basically it is a gravitational flow, and there needs to be a slope, a gradient in the pipe, otherwise the water will not flow down. Siphonic systems are very different when it comes to that. There, the pipes are fully filled with water. A baffle is used, a special inlet basically preventing air to go into the pipe when there is water on the roof. And with this, you get a siphonic system. You basically get all the weight of the water in the pipe sucking the water from the roof. And that creates much higher velocities in the pipes, and that has all kinds of benefits. So let me give you a short comparison of how that works. So on the left, you see a standard conventional system, and on the right, you see a siphonic roof system. Wavin has the Wavin quick stream system for that. Well, ultimately, it gives a 50%, up to 50% cost saving to use a Wavin quick stream system. I was just telling you that due to this siphonic idea, you have much higher velocity in pipes. This basically means that more water can be transported through that pipe, but also it means that due to high velocities, the pipes will not contain any pollution because they will basically flush out. And with those high velocities, also the diameters of the pipes can be much smaller, which in the end results in a cost saving. But also the pipes do not need to be at a gradient. So if you have the pipe, it doesn't have to be lower at the end, it can be horizontal, which saves a lot of space when it's attached to the roof. But it's also the benefit that basically you can connect all the pipes and go down with just one downpipe. So you need much less pipe length, whereas in a traditional system, all inlets of the roof need one downpipe. And then you need a gradient system, which you need to dig into the ground. And all of that is not needed anymore because it can be connected to the roof and then installed inside the building, also improving the durability of such a system. And in the end, it also results in more freedom of the design. So there's no trenching needed to put the pipes in. So that space is now suddenly available for anything else. But especially when you look at the roof, with the lower amount of downpipes, it's much more flexible system, and you can basically place the outlet anywhere that you want it on the roof, because you don't need a downpipe below it. So you can have the space below it available for the activities that are in the building. So lots of benefits. So I would recommend to use, especially for larger roof areas, a quick stream system, but not just because of those benefits, but also because I think it's very beneficial to work with Wavin. We have a complete software package working with AutoCAD, and we have a complete BIM Revit package where you can design the QuickStream system in. So it will make it very easy for you to implement this in a design. It will save you a lot of time, and you can be sure it is a reliable system. We have a special software package to make a full calculation to make sure that a siphonic system works. You need to do some calculation. That is the only thing that you need to do extra compared to a conventional system. You need to make a calculation because there are a few risks in such a system which you can avoid by doing the proper calculation. Well, we have a very good software to do all the checks, checks on whether there's a good balance, that the outlets get sufficient water, that they don't start getting air in the system, but also that the pressure in the system, the under pressure in the system, is not getting too low, that you get damage to the pipes. It makes sure all pipes are fully filled and that they always be clean. So all the checks are done. If all the checks are good, then we release such a system for actually being built. With our calculations, you can be confident that your siphonic roof system is also working correctly. And we should realize that these systems also need to be very robust. These systems are made out of PE, polyethylene pipes. If you have 100 meters of pipe with a change of temperature of 30 degrees, then the length of the pipe will change with 60 centimeters. It means that enormous forces can actually start existing on the pipe connections to the roof. And therefore we have a special bracketing system. We have this fully calculated through with a finite element method and agreed by an engineer that this is a system that does the job that is actually needed to do. So you can be sure that the system will not break in changing weather condition, changing temperatures. And besides that is also a really easy to install system. So also installers will like it because yeah, you can just place the pipe and tie it with very limited effort. And this is recognized in the market. We have quite a good track record. We are in this market for 36 years. And we do small projects for small roofs, but also roofs to more than 200,000 square meters. So only roof drainage is what we can do, but we can also supply full systems when it comes to water management. And of course, that's what I'm going to present also to you today with all the other steps. We've done projects for leading brands in the world, for the Olympic Committee, for IKEA, BMW. Well, look at the brands. These are not the small ones, and they really appreciate our expertise and reliability. The application for such systems is, well, anything with a roof, and especially a larger size roof, so like the logistics centers, shopping malls, supermarkets, airports, hotels, hospitals, large office buildings, factories, etc. A few pictures of projects where we were, and also some references of large projects that we have done in China, for example, in automotive, but also Pirelli, the tires, for the World Expo, the building, and one of our largest projects for ABB, the electronics company. Yeah, we really know what we do, and I hope you will also trust in our systems when it comes to that. Let me take the next step. We do not only need to drain the water from the roof, but also from the other hard area, which is the street or the square or whatever. And I'm presenting this. I am presenting this to you as a global product manager. I'd like to have said that also. So I'm going to take you through the portfolio that we have around the world, but not always specifically in every place in the world. So what we do in Europe, we have a great drainage system with gullies. As you can see, we have a whole range of different gullies, as there are different practices in every country. But when we talk about road drainage, we know that this should be durable systems. One of the things that we have been doing is actually testing our gullies in front of the factory of Scania, the big truck manufacturing, because they had big problems with concrete gullies that would break every time. And we have installed our Tegra road gully, which is super robust, and they are very happy with that. Since it was installed 2.5 years ago, it's working perfectly, no damage at all. So it shows that plastic systems can actually be much more robust due to the flexibility and the design of the material. With that, we make sure that this is something you can rely on also for long term. And not only when it comes to the forces that go on it, but also on the performance. We have designed a gully where we make sure that it will always drain the water out, but also prevent pollution to go out. And that's what you can see on the right side. You can see an outlet and a circular filter. Water will flow through the filter, and it can from all sides go to the outlet. That means that it will not easily block, but it will hold all the litter that is running from the street into the stormwater system, and in the end that ends up in our channels and our seas or oceans. And last but not least, this is a fully recycled product. It is one of our ambitions to not make any new products anymore in stormwater management that are made of virgin plastic. We all aim to do recycling, which is very important when it comes to CO2 emissions and our environmental footprint. So the next step is, once we have collected the water either from the roof or from the road, and we have done the basic filter with the gullies, we should look at what does this water contain more, and does it require more treatment, especially looking at the further down the chain. For example, if you want to reuse the water, it is very important that the quality of that water is good. So we do have a portfolio of that as well, especially in Europe. That is a portfolio of oil separators, hydrodynamic separators, sediment separators, and special substrate filters, where we use special substrate to take heavy metals out of the water. So there's a whole range of products depending on the situation where you are, what kind of pollution that you have, and what kind of drainage system you have behind. It might be different, for example, if you have your stormwater drained into a combined sewer system where also foul water is in, that in the end will also be treated at a wastewater treatment plant. But in many cases nowadays, these systems are separated, and it's important to also install filter systems, especially if you want to also drain water into the ground, to make sure that the groundwater remains of good quality, as groundwater is the prime source for drinking water as well. That was about the filter system. Then a little bit on the transport. Of course, you can transport pipes with traditional pipes, but we as Wavin actually would promote infiltration pipes. And the reason is that in many cases, it is beneficial to actually drain water into the ground if it's possible. So if you have a groundwater level that is actually going down all the time, you want to replenish that, recharge that, and that can be done with an infiltration pipe. An infiltration pipe basically is a leaking pipe. It's a pipe with slots and a geotextile around it to make sure that it doesn't no soil of the surroundings will flow into the pipe, but only water can flow out of the pipe through the walls. And this works like that if you have a low flow with moderate rains through the pipe, water will not reach the end of the pipe, but it will flow into the ground, recharging your groundwater and also avoiding supercharging the sewer system further away. If you get higher flows, then still part of the water will drain through the pipe wall into the ground. But if there is too much water, it will just continue to flow and it will actually work as a conventional pipe, and the water is drained via the pipe to the end of the system. So something to consider in your designs if you are doing things around the building. So that is also that was the example. For example, after your downpipe, you could connect it to a infiltration pipe before going to a infiltration tank or an attenuation tank, as you can see on these pictures. So connecting your rainwater system to an infiltration and attenuation tank. Why would you do that? Well, floods in urban areas do occur. Of course, they can occur by an overflowing river, but what I would like to focus is in floods due to rainfall. They occur because basically the sewer system cannot handle all the water. So all the pipes are fully filled, and then more water is coming. It needs to get out somewhere. You can basically get overpressure on your system, and water will from every manhole will just get out like you see on this picture, and it will flood the streets. So what do you need to do? You need to create space for this water to go to instead of the sewer, which cannot handle it. And that is what we do with our infiltration and attenuation tank. We basically create an area or a volume below ground that can absorb all the rainwater during the heavy rainfall and either infiltrate that into a ground, an infiltration tank, or just hold it back and with a gradual outflow, put it back into the system without overcharging it. Here you can see a few examples below a car park of trucks, but a specific example here near a stadium in Oslo, Norway, where you can see on the top part they are digging this big hole to actually have all the rainwater drainage from the stadium and the car park going in there, and then after that connected only to the sewer, not overcharging it. So to show it a little bit more schematically, on the left two pictures, you see water is going in and it will soak into the ground, the infiltration tank, or water is going in and it will stay in the tank, but with a flow control, a limited outflow is created. So it is a buffer system basically, where the water is held in such a way that the sewer system is not being overcharged. This is very common practice in many new build areas, because basically the regulation in Europe is like that, and I'm not sure how that is in Malaysia, but the regulation is that if you build something new, you should not increase the risk of flooding due to rainwater. So a solution is mandatory, and this is the very, very common solution. We have two products to do this with, a Cubic Plus, which we call the optimal solution, and also a more practical solution with our Aqua cell. Our Cubic Plus is a system that is very, very open and is made to last. Made to last means it's designed for and is made to last for at least 50 years. That is when it comes to structural strength. So if you put it below ground and you have traffic driving over it and everything, it will stay there for 50 years without any problem, but also made to last to make sure that it keeps on working as it should. So even if you have, for example, some pollution in your tank, you will be able to inspect and clean it. And therefore the open structure that you can see on the right side is very, very important, that you can make sure this tank will last the full lifetime. There is another benefit for the installer. It is very easy and fast to install. On the bottom, you can see a standard traditional system. It is not even built for 1/3, while in the same time, you can build a Cubic Plus system completely. For the designers and architects looking for a solution around the building, we also have the opportunity to include it in your BIM Revit design. We have a full package for these products. You can rely on us. We have 25 years experience without any problems to our tanks. That is also confirmed by the testing that we do. This system is completely tested. We did all kind of structural strength tests, and we have those tests all approved by all the major certification institutes in Europe. For example, for Germany, France, the UK, and for the Benelux. And we have the other system, which is the Aqua cell system, recently introduced, made of 100% recycled material, and therefore a sustainable product, but also sustainable because it's a space-saving product. As you can see on the right side in the truck, you can stack this unit very efficiently, creating like 4 times less volume than you would have if you start building the tank. So it saves up to 4 times space in a truck. That truck doesn't have to drive, so it is also lowering your CO2 emission, but also making logistics on the building site easier, and the space that you need on the building site or in the warehouse. So this system is also all kind of benefits and will work in similar conditions as a Cubic Plus system. Well, if we have water in a tank, then we could actually not just do things like I just told you. We could also do another thing. So we could infiltrate it into the ground. We could hold it back, feed it back into the sewer system just gradually so it doesn't overcharge it. Or we keep it as long in that tank that we can actually start using it. But there is, of course, a contradiction. And that's what I would like to talk about shortly. So an infiltration and an attenuation system should be empty as much as possible. Because if this rain is coming, the tank should be empty to absorb all the rainwater. So if it is full, it doesn't do anything, and you will still have flooding. On the other hand, if you have that volume of rainwater in your tank, it would be actually great to use it, but then you keep your tank full. So here in Europe, we have an advanced smart control system, Storm Harvester, where we are actually managing the water level based on weather predictions. So if there's no rain coming, we can hold the water in the tank, and then it can either infiltrate because the rates are slow, but we can also reuse it. For example, for flushing toilets or for irrigating during the dry spells during the year. And in that way, you can make dual use of the tank by using and introducing smart technologies. And Going one step further from reusing rainwater for irrigation, we also have a solution for urban trees. As said, heat in a city is a huge problem. It has big impact on health of people, and therefore trees, also according to one of the largest consultants in the world, McKinsey, trees are the best solution to cope with an urban heat island effect. And I'd like to talk to you about that. So it is very important because of the well-being of people. It is also a financial benefit. And that is very interesting. Areas where trees are planted have more value than areas without trees. So basically it increases real estate value. And trees work as a air conditioning for the city. So they can cool down a city by 2 to 3 degrees. And just to give you an idea on what the effect of a tree is, one tree equals 20 to 30 air conditioning units. So it can have major effect. So meanwhile, we have seen also that the urban heat island effect, the effect that cities are even hotter than the outside, is 5 degrees to 10 degrees more heat in the city. So it's even more important to have trees in the city, not just outside of them. A nice thing of trees is as well that they increase the air quality. They filter out all kinds of harmful dust and pollutants, and they take out carbon dioxide out of the air. And last but not least, it is improving urban biodiversity. It's about the birds and the bees, so to say. So actually, cities are not designed for trees. Cities are designed for transport and living. So they are paved, there are streets, there are parkings, there are buildings, and for all of that, water is not infiltrating into the ground and making it available for roots of trees. Most of that water, most of the stormwater system are actually designed to drain the water away as fast as possible. So it's not even available, it doesn't even come available at all. And that means basically that it is not a good environment for a tree because of drought, but also we change the soil types. We put in sand because we want to build a road which is solid. Sand doesn't have any nutrients for a tree. It is well compacted, so it also doesn't have space for roots. So basically a city environment is a bad environment for a tree. And on the other hand, a tree can have negative effects as well. Not the tree above ground, but the tree below ground. The tree roots can be a pain. Because they keep on searching for water. If it's not below ground, they start searching it for on the surface, damaging roads, creating all kinds of unsafe situation on roads as well. They can also penetrate old clay and concrete pipe system with cracks or joints that are not sealing off properly, and your total sewer system can get blocked due to that. But also during operations like piping work being done, the trees can cause quite a difficulty with the roots that are all over the place. So how can we combine the benefits of trees with the urban environment, avoiding the negative effects of roots? Well, that's a tree tank. The tree tank is a perfect solution to create the optimum for trees and the optimum for the city. So basically what we do, we create a tank below ground that can be filled with the right soil, with the right air amount and water amount in it, and we plant this tree inside that. This is then the perfect condition for the tree to grow, and the tank will take all the forces of a road construction, of a square or whatever is on top. So the loose, good soil for the trees can be inside the tank, what doesn't need the level of compaction to support the infrastructure use of the city. So it's a confined space. So the nice thing is the tree roots will not start growing outside. They will not break the road surfaces. So that will also avoid a lot of damage and costs to that. It will prevent unsafe situation. And it might even have a positive effect on your stormwater management because it has a volume to store rainwater as well. Well, how does that look like in practice? Here you can see the tank all the way below ground. On top, there is full paving. This is actually on top of an underground car park. So the bottom is concrete, then we have a tree tank, and then we have a concrete topping or a paved topping again for a shopping area. And a tree is planted, and a tree likes it. It is actually the conditions that you would say, well, how can a tree properly grow there? Because it's fully artificial, but with this tree tank, it is thriving. And this is after the first year. You can see the same tree standing there. It has perfect leaves on it. It really is growing and growing. And in this way, we can contribute to a climate resilient city, but also to a great, pleasant, livable, lovable urban environment. So that were the steps if we follow the water from the roof to a tank and then reuse it and even build the nice areas for trees. But in some cases, unfortunately, we need to drain the water. And if you drain water back into a sewer system, as said, it can be overcharging a sewer system. So to make sure that this tank is not draining into your sewer system very, very fast and still overcharging the system and it creates flooding, we have special manholes with controls in them. Those can be, for example, vortex valves, which you see here examples. Those valves actually make sure that there is a constant flow out of the tank, not too much, to make sure that it's all controlled and the sewer can still handle it. Alternative, you can use an orifice plate, but it has different and not as good hydraulic properties. Also, weir plates can be used or pumps. So anything basically can be installed in one of our manhole, which we can make custom made. And then in the end, water is flowing to the pipe system, pipes and the chambers. So that is what you can see here. We have a big range of chambers, manholes, inspection chambers. We have solid wall pipes and twin wall pipes, going from 100 to 800 millimeter pipes, and inspection chambers and manholes from 315 to 1250. So basically always something that suits. And then it is important to realize what we do is quality. That's what we stand for. We make sure that all our systems have a lifetime of at least 60 years. And we design things to be easy to handle and, if needed, customizable. So all in all, if we follow the water either from the roof or the street, we can clean it, we can infiltrate it, we can buffer it to make sure that water doesn't overcharge the sewer system, and we can reuse that water even with some smart controls going into the going back into the building, for example, for sanitation or for irrigation. And we can even make sure that also trees have the perfect environment to grow, and we can even feed it with the water from those tanks. And if that is not possible, we can drain the water via controls into the pipe system. So for every part of the rainwater management, there is a solution. We can make cities climate resilient. So let's build climate resilient cities together. I hope you enjoyed this webinar so far, I was honored to present this to you. Before we go to a Q&A, I would like to ask your feedback. It's very important for us to also hear from you. If you liked this webinar so far, you can scan the code and fill out the form, and you can even win an exclusive Wavin gift. So very much recommended. And if you like this webinar, we will have more. Today is, of course, about climate resilient cities, solving the puzzle of rainwater and stormwater. The upcoming webinar is about safe and efficient water supply. And that's on the 14th of October 2021 from 3 to 4 p.m. Singapore time. So if you scan this QR code, you will have access to all the upcoming webinars. You can see what we are going to do. So thank you very much for your attention. And I hope that I have contributed to some kind of your ideas for the new projects that you are working on. Would you like to contact us? Please visit wavin.com/Asia or send an email to wavinapac@wavin.com. So that's it for me so far, and I would be happy to answer questions if you have those. Thank you very much.
Thank you, Mr. Geertjo, for the insightful presentation. Now we will move into the question and answer session. Reminder to all participants, you can post your question in the chat box or Q&A box provided down there. And not to forget to Facebook live viewer, you can put up your question in the comment section and we will share with the speaker. So without further ado, I'm going to read out some questions we received from the chat box from Zoom webinar. It's from Dijk. The question is, what is the material used for the pipe of the siphonic system?
We use polyethylene pipes for these systems. So it's a plastic pipe, that is perfectly suited to also manage at high velocity water flows.
Okay. The second question, also from the same person, Mr. Dijk. The question is about my experience with siphonic system is the hammering effect. So how do you resolve this problem, and what is the support system for this?
Yeah, that's a very good question, and I think there the important is to understand how the system works exactly. So it's very important that from the design phase, a system is fully calculated to test it. And basically the hammering effect is the result of cavitation. That will create a shock wave then through the system. But if the system is well defined and basically all the inlets are well balanced, then you will not have cavitation nor hammering effect. So it's very important to have a solid design of the complete system before installing it, and with our software we can help doing that.
Okay. All right, and then we go to the third question by Mr. Yi Lon Chong. Do we need to allow for an extra downpipe in case the single downpipe is stuck?
Well, that could be a solution, but it would be very strange if that downpipe is stuck. Of course, the dimensions should fit. In the case of very large roof drainage systems, we also have multiple downpipes, but you at least need much less downpipes than in a conventional system. So depending on the size, what you need, but you should realize that well, most of the fines can stay in pipes with up to 0.5 meter per second of flow velocities. Within these pipes, we reach flow velocities up to around 5 meters per second. So the flushing effect is very good. So to have a pipe really being blocked, is very uncommon, and it also has to do with a proper inlet system which prevents anything to go in, and if it goes in, then it will also be flushed out.
Okay. Okay, we received a question from an anonymous. He said that he loved the tree tank idea. Just want to ask, how long would it last? What is prohibiting the roots from growing beyond the size of the tree tank in, say, 30 years? Can it be used in elevated sky garden as well, or is it too heavy?
The tree tanks are just like our infiltration attenuation tanks. Our pipe systems and manholes are designed to last for 50 years. So structurally, they will last for that period. The size of the tank is determining whether you can keep the roots inside. So if you build a very small tree tank, then you can imagine that when the trees grows, also the roots will start expanding beyond the tree tank. So it's important to design a tree tank based on the type of tree that is planted, and create sufficient space for the tree to actually be able to grow to a large level without going into the ground. So it's in the design there.
Okay. All right, we go to the next question from Mr. Edmund. A tree is planted in 3 tanks able to withstand severe storm since the root cannot spread.
Could you repeat your question once more?
Sure. He asking that, are trees planted in 3 tanks able to withstand severe storm since the roots cannot spread?
Yes, they can. It is false to assume that the roots cannot spread. Basically, what you do with a tree tank is the space that the roots would normally take, you now create a confined space where they still can root properly. And it is a flaw that people believe in very much, that a canopy of a tree is also the shape of the roots below, but the roots generally only spread horizontally, like up to 1.5 meters deep. So in most cases, there are specific trees that do go deeper, but most trees actually spread much more horizontally than their canopy. So it's important that with the tree tank, you create sufficient surface that this tree can actually anchor itself properly. And in the beginning, we have an anchoring system in the tree tank to have the tree once solidly placed before it is actually having its root to make to have sufficient stability also for storms.
Okay. All right. Seems like we received a lot of question here. So I'm going to read the next question from Mr. Darren Koo. He asking that, can an existing gravitational RWDP system be converted to siphoning effectively and affordably?
That is a very interesting question. And I would, unfortunately, my first response would be no. Or at least not with the same pipes. Because the thing that you would need to create is that you have fully filled pipes. A siphonic system has much higher velocities. So if you would use the same pipes, they are too large to actually create the siphonic effect. So if you would want to change this, this requires to also change the piping system and the roof inlet to make sure that there's no water, no air in the piping system. So basically you need to replace the full system if you would like to do this.
Okay. All right. Question from Mr. Martin Lee. Have this product received Malaysian Serum certification?
The products that I have presented are the products that we sell throughout throughout the world, especially in Europe. I think so far we have no certifications yet in Malaysia, but maybe Kit, you can respond on that.
Hey, hi everyone. I'm Geertjo. I'm in charge of Malaysia market. Our dealers and ourselves is presenting to the local authority Syrim, and since this product is quite new in concept, we have to present our case and we have to do a voluntary Syrim certified to Malaysia standard at this moment. So we have a range of water filtration system. Some of the products they don't have anything close to it to certify as a Malaysia standard locally. So we had to do, like, for example, the siphonic quick stream system, we had to do a voluntary test with Syrim. And we are doing that on the way. Yep.
Thank you, Mr. Kit. So we're
Yep.
moving to the next question. The question is, the depth of the tree tank is about 450 meter. It is sufficient for trees. Usually, landscape architect will recommend about 1 meter depth.
Sorry, could you speak up a little bit? It's difficult for me to
All
understand.
right. I'm sorry about it. I'm going to repeat the question. He is asking, the depth of the tree tank is about 450 mm. Is it sufficient for trees? Usually, landscape architect will recommend about 1 meter depth.
Yeah, so the tree tank, as I showed it, is a 60 millimeter for a single layer system, and it can be placed underground. But if you would need 1 meter, we can also make a double layer system, so it can be easily constructed in 1 meter 20 as well, if that would be recommended for the specific trees. That is no problem at all.
Okay. A question from Mr. Badru Rijal. Could you please wrap up the flow of your design diagram in 1 sentence or simple explanation, perhaps?
In 1 sentence, my design diagram. Oh, that is, well, let me try. It is following the drop from where water is collected, trying to use it and make sure that it's clean as much as possible, and only if needed, drain it back to the sewer. That is my try of doing it in 1 sentence.
All right. So the next question, is the pipe size applicable to local equivalent?
I'm not sure I understand the question properly. So,
perhaps you can share it later. I will share the question to you. Maybe it can be written and we can share to the participants. We're moving to the next question. It's from Mr. Kwek Chai Kim. Can the tree tank be used in the rooftop or podium deck, and what is the depth required?
yeah, so the very good question, and actually it is perfectly designed for that. And the example that I showed you is a podium deck construction. It can be used also on roofs. There, of course, the roof should have the capacity to handle the weight of a tree, but it can perfectly be used on roofs as well, like podium decks. We have a system where we are starting with a 40 millimeter high system, 40 centimeter high system, sorry, and then we can go up to multiplications of that, or 60% or 60 centimeter and multiplications of that. So 40, 60, 80, 120, all is possible.
Okay, a question from Mr. Jung Wai Ho. Can the product replace OSD tank, and can authority accept this product? Any precedents?
I'm not sure what I don't think I know what an OSE tank is. So it's difficult for me to answer the question in that case.
Okay, now we'll do the same thing. Maybe we can write the answer later to the participants. We move to the next question from Mr. Darren. What is the difference between infiltration and attenuation tank?
The difference in the end is the wrapping around the tank. So the tanks are wrapped in a geotextile. A geotextile is a woven or non-woven material which is permeable. So water can flow through the walls of the tank into the ground. If you have an attenuation tank, the outside of the tank is sealed, and we do not use a geotextile but a geomembrane, and a membrane doesn't allow water to go through, so water will just go from the piping system into the tank and then from the tank again into the sewer system. That is the difference.
Okay. All right. I think I have read out all the questions from the chat box from Zoom webinar. So thank you, Mr. Geertjo, for your sharing today. If you need further info on the products and Wavin company, you may contact their personnel. We will share their contact at the end of the webinar. Ladies and gentlemen, before we wrap up, please be informed on our next event titled The Joy of Missing Out JOMO in Construction Dispute, How on 2nd October at 11 a.m. by architect Hang CM. You can register via link as stated in the poster, or you can refer to the chat box as we have shared there too. Once again, don't forget to do your sign up to get CPD point. And thanks all for joining our PAM online series. I'm Nani Muhammad Noor. Stay safe and have a good evening. Assalamualaikum.